Let's do examples 3 and 4, where we're asked to find the sum of the convergent series. If I look at example 3, I have the sum from n equal 1 to infinity of 2 over 2n plus 1 times 2n plus 3. Well, right now, all I know is the telescoping series, and I know that the telescoping series have that minus sign, and then the other thing I know is geometric, and I know those geometric series are that sum from n equals 0 to infinity of a times r to the n, so a number raised to a power. Those are the only things I know thus far. Well, this doesn't look telescoping, but it definitely doesn't look geometric because nothing's raised to a power. But this is a fraction. And I know from chapter 8 that I can decompose this rational expression into the sum or difference of simpler fractions. So I have to start this problem off by doing partial fraction decomposition. For partial fraction decomposition, don't forget we had 2 over 2n plus 1 times 2n plus 3, so the original function, and that's going to equal, we have two different denominators, 2n plus 1 and 2n plus 3. Both of them are linear, so over 2n plus 1 I write a, over 2n plus 3 I write b. Then I need to multiply through by the denominator 2n plus 1 times 2n plus 3, and I'm going to do that to both sides, 2n plus 1 times 2n plus 3. On the left, everything cancels and I'm just left with 2. When I distribute to a, I'm just left with a times 2n plus 3. And when I distribute to b, I'm left with b times 2n plus 1. Let's use convenient values to find a and b. To get rid of this term, I would have to let n equal negative 3 halves. Well, if n is equal to negative 3 halves, I would have 2 equals a times, well, that becomes 0 plus b times negative 3 halves times 2 is negative 3 plus 1 is negative 2. I have 2 equals negative 2b, which means that b is equal to negative 1. Now let's get rid of this term. Well, what would I plug into that? Well, I'd have to plug in n equal negative 1 half. So if n is equal to negative 1 half, I'd have 2 equals a. If I plug in a negative 1 half, that's going to be 2 times negative 1 half, or negative 1 plus 3, which is 2, plus b, and then when I plug that in here, that's going to be 0. So that term cancels, and I get 2 is equal to 2a, which means that a is equal to 1. So I can rewrite this guy here as the sum from n equal 1 to infinity of a, which is 1 over 2n plus 1, and then it should be plus b, but plus a minus is really minus, and then it's going to be 1 over 2n plus 3. Well, now I can see that I'm telescoping. Why am I telescoping? Because of the minus sign. Now to determine if this series converges or diverges, I need to find the sequence of partial sums, and then, once I have that, if the series converges, I can find its sum by taking the limit of the sequence of partial sums. Let's start by finding that sequence. S of n is going to equal, when I plug in an n equal 1, I have 1 over, well, 2 times 1 plus 1 is 3, and then minus 1 over 2 times 1 plus 3 is 5. Plus the next term, plugging in an n equal 2, we'd have 5, and then over here we'd have 7. So 1/5 minus 1/7, plus plugging in an n equal 3, you're looking at 1 over 7 minus 1 over 9. Now we need to plug in an n equal n minus 1. We'll be really careful here. What we're going to do is do it on the bottom and then erase it just to make sure we don't make any mistakes. So if I plug in an n equals n minus 1, that would be 2 times n minus 1 plus 1, which is 2n minus 2 plus 1, or 2n minus 1. Minus, if I plug in the n minus 1 over here, that's 2 times n minus 1 plus 3, or 2n minus 2 plus 3, which is 2n plus 1. Now n equal n. For n equal n, it's just going to be itself, which is that 1 over 2n plus 1 minus 1 over 2n plus 3. And go ahead and erase this bit down here. Now, what, if anything, cancels? Well, the negative 1/5 and the positive 1/5, the negative 1/7 and the positive 1/7. If we would have written the next term here, this would have canceled. Our negative 2n plus 1 and the positive 2n plus 1 will cancel. And then if we would have written the next term in front of n minus 1, this would have also canceled. Therefore, what's left is s sub n is equal to 1/3 minus 1 over 2n plus 3. So this is the sequence of partial sums. How do I determine if the sequence of partial sums converges or diverges? Well, for a sequence, we have to take the limit as n goes to infinity of that sequence. So we say the limit as n goes to infinity of 1 over 3 minus 1 over 2n plus 3. Well, that's going to equal 1/3 minus 0, or 1/3. Since this was a number, we knew that that meant that our sequence converges. Well, since the sequence converges, that means that the series here converges. And since the series converges, we know that our sum is equal to the limit. Our sum is equal to 1/3. What about example 4? Example 4 is the sum from n equals 0 to infinity of negative 5 over 9 raised to the nth power. Well, this is actually geometric because it's a number raised to a power. So for geometric, I need to find the absolute value of r. Well, r I know is negative 5 over 9. Therefore, the absolute value of r is going to be the absolute value of negative 5 over 9, which in this case is just 5 over 9. Well, 5 over 9 is a number that is less than 1, therefore I know that this series is going to converge. Why? Because if the absolute value of r is less than 1, the series converges. If the absolute value of r is greater than or equal to 1, the series diverges. Now I need to find the sum. Well, recall the sum formula is a over 1 minus r, where a is equal to that first term. So let's determine what the first term is, and then after that, we will find the sum. So the first term would be when I plug in a 0. So when n is equal to 0, I would get negative 5 over 9 raised to the 0 power, and negative 5 over 9 raised to the 0 power is 1. Therefore, this is my a. So my sum is going to equal 1 over 1 minus r. Well, r is negative 5/9. So if we work that out grabbing a calculator, we would end up with 1 divided by 1 minus negative 5/9. If we hit enter and make this into a fraction, we get 9 over 14. So our sum is 9/14.